Hi, this is Ms. Delosier, and these are your notes on momentum. So the first thing that we're going to have to talk about is what is momentum. So let's start with an example. Let's say I have a Mack truck, and that Mack truck is going 60 meters per second. And let's say that I also have a little car, and it's going 60 meters per second. Well, my question is, which of them is going to have more momentum? And before I can ask that question, I need to tell you what momentum is. So momentum is where you have more inertia in motion. More inertia in motion equals more momentum. So in this example, where do I have more inertia in motion or more mass in motion? So I'm going to have more mass in motion here with the Mack truck because they're both going the same speed. So when I'm talking about inertia, I'm talking about simply mass here. If they were going different speeds, our answer would be a little different. But in this example, it's just going to be based on mass. So let's look at how speed can affect the mass also. Momentum, mathematically, is going to be defined as momentum equals mass times the velocity of an object. And we represent that in an equation form as P equals m times v. I know that it's weird that momentum is the letter P, but we can't use m because m is mass, and that's in the same equation. So it's little p equals m times v. That's our momentum equation. So let's look at a couple examples. Let's say I have a truck going 50 meters per second and a car going 50 meters per second. Which of them has more momentum? Well, we have to kind of know something about the size of the objects. So let's say that the truck has twice as much mass as the car. So if I have a truck that's twice as big as the car, but they're both going 50 meters per second, which one is going to have more momentum? The answer is going to be my truck has more momentum. So now let's look at an example where I have that same truck going 10 meters per second and that same car going 100 meters per second. Well, remember, the truck's only twice as big as the car. So if I look at that situation, which one's going to have more momentum by this equation? It's going to be the car, because the car is going 10 times faster than the truck, but the truck's not 10 times bigger than the car. And then finally, let's look at the last example. If I have a truck at 0 meters per second and a car at 0 meters per second, what's going to be the one that has the more momentum? Well, this is kind of a trick question, because if they're both going 0 meters per second, that means both of their velocities are 0, right? Which means both of them have 0 momentum, which means that their momentums are in fact equal. So let's look at the Juggernaut. The Juggernaut is a villain, and let's say that he has a speed of 30 meters per second to the west, and he has a mass of 225 kilograms, and I want to find his momentum. So I would do that by using the equation P equals m times v, and I'm going to go ahead, and that's going to be 225 times 30, and that's going to give me a final momentum of 6,750 kilogram meters per second. Kilogram meters per second is the unit for momentum, and technically this would be 6,750 kilogram meters per second to the west, because this is a vector quantity, because it's based on velocity, so it has a direction. That's all that means. So that's it. That's the basics of how you solve for momentum. It's a pretty simple equation. We're going to be doing some things that are a little bit more complicated with it in the next couple days, but I just wanted to give you a really quick basic introduction to momentum.